Okay, I want to do an experiment. What I want to try is I got these straws here, these stainless steel straws that telescope, and they have these rubber seals. And I want to see if they can be used to telescope parts of the T service when I put it in the car. The travel, just to kind of give you an idea, the travel that it can extend is also the travel that it has to have stored. So I can cut this down, but if I cut it down, then, if I cut it to this, then I can only extend it that same amount. So that's something to keep in mind as I'm engineering this. But what I want to see is just how far I can go and still get hot water. So I'm going to do an experiment where I brew some just plain water, and I have a thermometer here. It's a little messed up, but I'll measure the temperature of the water, brewed kind of regularly in the normal setup, and then I'm going to extend this really far. I'll probably try it with both. I want to see if I can go here and like here and brew out here, and then I want to try extending it. Like, what if I put it like way out here, like like super far away with that? Will it still brew that far? Can it push the steam water that far? So that's the experiment I want to try right now. So anyway, I'm doing this. I haven't done this before, so let's give it a try. This is my old setup. I now have a 3D printing pen, and I use a pen to make a little bracket here, and also to extend this because the water was sloshing out. This is plugged into a GFI just for safety purposes. So there's a fuse on the outlet. So that's generally things in the kitchen or bathroom are GFI, mean ground fault interrupt, meaning if the electricity grounds to the ground instead of returning back to the plug, then it will blow a breaker, and or it'll blow and prevent you from getting shocked. So it's not 100%, but it's much better than nothing, better than plugging into the wall. There are kind of exposed wires here a little bit. Alrighty, let's give this a try. So I'm going to invert my water. Let's see if it spills with now that I've got the new wall here. Oh, much better. So it is leaking. It's leaking out of the... Okay. It's just a little higher, and that's why it's leaking. But it stopped. Alright, I'm going to press the start. And it is now brewing. I don't know if you can see the little blue light. When it brews, it tends to make the nozzle fold over, so I'm expecting that. So let's see. There it goes. I'm going to brew this whole bottle of water, and then I'm going to extend everything and brew again. This time the water's going out of the bottle. That's good. This is a differently shaped bottle than the bottles I had before. The neck is shorter and allowing the water to come out of the bottle. Alrighty. We'll wait till it finishes brewing. One of the things I like about these stainless steel straws is that they don't leak, and they can withstand hot temperatures as well. And so one of the things with this one, though it has a hinge to it, that hinge leaks. It's meant to leak back into the, you can even see it leaking. It's meant to leak back into the water reservoir, the way that it's this is designed. But I want to make it so that that I can have an elbow in there that is not meant to leak. Alrighty, it is done. Let's measure the temperature of the water. It's going to be hot. Cough, cough. Alright. Let's see what we got here. It's 220 at the very top end. So we're passing to 180, 190. Looks like it's kind of staying still at 190. Alrighty, so so this brews water into this mug at about 190. I'm going to stop it and then do one of setup for the other one, the other test.